Hey everyone, Stefan here from Python Dev, and in this quick coding video, I'm going to talk about how to find the length of an integer using a while loop. Pretty common question when you're first learning how to use while loops in Python, and pretty, common to, pretty common operation to be able to do those kind of things. So we have our test input here, so this would be one length, this would be two lengths, and the theory behind this is if you just keep dividing it by 10, it's going to get smaller and smaller, and the number of times you divide it by 10 is going to be the length of an integer. So here in this example I wrote down, if the input is 123, you divide 123 by 10, you're going to have 12 with some remainder, so that's one division. You do it again, take the answer to this, divide it by 10, you end up with 2, and then you do that again, you have 0, and then the length is 3. So I'll just quickly code this up. So finding the length using a while loop, and then I'll discuss two other ways we can also do this, and then use the timeIt module to figure out which one is the more optimal Pythonic best ideal way to find the length of integer. And kind of talk about some Python theory and stuff along the way. So I'll just while yeah, so while test is greater than 0, just do test. I think you can do divided by equals 10. Num length, so equals 0. Each time we do this operation, we'll increment num length, so we'll do plus equals 1. So this is some Python syntax to do some operations and then assignment in one operation. It's basically the same thing as doing this. But this is a little shorter, a little more Pythonic, a little more zen. We like doing these things. And then I think we can just do print num length here at the end. And since we're using Python 3, because everyone should be using Python 3 at this point in time in 2022, we'll go ahead and print that. Not sure if I just leaked stuff. No, I didn't leak anything. If you guys can get anything out of that, then you're pretty awesome. So we'll run this in the terminal, and our length is 350. So obviously that's not what we want to do. We want to do floor division. So basically it will always round down. I think the 350 is because it was dealing with decimals, and that's not ideal. So, alright, if we do floor division and reassignment in one line divided by 10, we print the length. The length of this is 27 characters. So we can also do another, one-liner that's a little more kind of Pythonic. We convert our test input into a string, and then we find the length of that. So we can do length of string of test and just print that and verify that our two answers are the same. And they're not. This is 1. It should not be 1, and it's because of this reassignment right here, obviously. So let's just take this, move this. That doesn't matter that much, and we'll go ahead and show 27 equals 27. And lastly, our other kind of fancy way of doing this, basically to convert an integer to a string, you have to look at every single one of these and then convert that to a value, potentially using like some kind of lookup, and then a mapping, and then concatenate the string. So inherently you would think converting something to a string is expensive, or at least I thought so, which I'll talk about later on. So the last way we can do this, so this is using string conversion. This is the answer for using a while loop. And then the last way is using math tricks. So if you guys are all familiar, log base 10, so log 10 of 100 equals 2. So basically, 10 to the power of 2 equals 100. So this is like an inverse way of doing exponents if you guys are all familiar with your math classes. So using this little trick, if you take a really long number and you actually test this is no longer going to be the number we want it to be. If you take a really long number, we'll just reassign it. That sounds horrible. We'll do this above our loop. And you take the log of it, you can basically use that trick to find out how many digits are in it, especially if you take the like the rounded down. So we're gonna import math. I think you can do something like print math.floor of math.log10 of our input number. So if we print all of these should all equal the same number. So using logarithms, print using string conversion. Oh my gosh, can't type today. And then using while loops. And in case you guys are not super familiar with the while loops, this while loop will quit executing once our number is no longer greater than 0. So if you take 1 divided by 10, doing floor division, it would be 0.1, and then that gets rounded down to 0. And you can see this will stop the execution of our loop once we have no more numbers to figure out how long it is. So that's kind of the short gist of how this works. So we'll print all these numbers using logarithms equals 26, 27, 27. So apparently it's not math.floor, maybe it's math.ceiling and you round up. So now you can see there's 3 different ways to find the length of our integer, which is really neat and handy. And you would think doing direct math intrinsically would be the fastest compared to doing a string, because you have to iterate over stuff to convert it to a string, and then you have to store the representation of the length to be able to call this method. So yeah, you would think this is the fastest. You would think this might be the second fastest because you're not actually doing any conversion, you're just looking at the numbers. We'll go ahead and use the timeIt module to validate some of these theories. From timeIt, import timeIt. So this will let us do stuff. What's the fastest way to do this? So you have to convert things to strings with the timeIt module, or you can do it in functions. So I'm just gonna def get length while we import our number, tab this over, and then we return our num length. For this, def get length string conversion, input our number, hit page down. All right, so here we'll just return this. So obviously nice and short, clear, you can tell exactly what's going on if you're familiar with the built-in string conversion and length number. Math is a little trickier if you don't necessarily understand the logarithms, which for some coders that haven't been in school for 5-7 years, you kind of forget what this is actually doing. So importantly, you want your code to be clear, concise, readable, so other developers can understand what's going on, or well commented, so they can figure out that way. Which is kind of what this does. It's a little reminder that you can figure out a length of a number by using a logarithm. So 100, 2 rounded up is 2. I think if your input is 100, using this trick is not actually going to give you the length right. So I think it's actually math.floor plus 1. I think this is actually the correct formula. Yeah, it's gotta be, guys. Get length logs. So we input our number. So now we have functions that we can use to get the lengths. You know, we can put these in a nice handy module and we can import them, and then we can use the, you know, get the length with the logs, depending on how fast or slow we want our code to be. So we actually need to change this to be our input number. Same thing here. Get rid of this. Now our code should actually be correct, and get rid of this. So we're not looking at the global representation of test, and instead we're looking at the instance num that is defined within the scope of the function. So just to prove this works, we'll go ahead, same thing using our while loop, get length while nums test. So now we should only have 127 instead. These print statements are not relevant anymore, so we'll keep cleaning up our code as we add things and change the behavior. Alright, so now you can see using while loops, 27. This no longer is using while loops, but now we'll use our timeIt module to calculate how long these functions actually take to run. Because one thing with programming, even if you have an operation that appears ON, one ON operation is not the same as another ON operation and can result in your program running 10 times slower than another way. Which one of these actually ends up being that one? And you would think, at least when I argued this on Facebook, that I thought it was the string conversion. Hint, it's not the string conversion, and we'll see why using the timeIt module. So timeIt statement equals, you don't actually need to do this, you can just use it as a string. So get length while, pass in our test, and we use this as a string because the timeIt module will import it, or import that function and then do fun stuff with it. So we can specify how many number of times we actually want to run this function so that we can get a number that's easier to understand. Otherwise it's really small in milliseconds. And then we want our globals to equal the globals. Otherwise the timeIt module doesn't have the context of this function unless we actually tell it that it exists. And it exists as a global function that's declared within this module. So now I think I need to print this. So we can print the whole result of the timeIt. And we can see that using the while loop, it takes 0.02 seconds. I think this is 0.02 seconds. In other words, 23 milliseconds. And we can copy and paste this. And we can add stuff in our output to make it a little more clear for our user. So while loop time. And we'll copy and paste this guy. And then this one will be the string conversion time. And then this will be the logarithmic formula time. So now it's very clear what everything is, what functions we're using, how we're using them, all that other fun stuff that you want to have in your code. So this is the string conversion function calling the string conversion, and then timing it with the logarithmic formula, calling the length logs, where logs here is the logarithm and not like a log that you're outputting stuff to. So that could be a little confusing, but since this is supposed to be a simple demo, I don't care that much. Alright, so you can see the while loop time is 23 milliseconds. The string conversion time is 2.7 milliseconds, and the logarithmic formula time 3.9 milliseconds. And you would think, you know, if you're just doing direct math as like a one-liner, that this should be faster than the string conversion. And the reason that is probably not necessarily true is because we are actually using the math module to do the log10 and then the floor. I think we actually don't need math.floor here. I think you can just like do +1 and then convert it to an int. So the int conversion will automatically round it down. This might actually be a little bit faster. So you can see now our string conversion is 2.75 milliseconds, and then the formula time is 2.77 milliseconds. So both are extremely close, but the string conversion is probably actually a little more Pythonic in the sense that it's easier to read. And since Python, since Python is interpreted by C++, this string conversion is written in C++, and then this length is written in C++, which is highly optimal compared to probably the math library, which is written in Python and then converted to C++. Whereas this while loop is executed completely in the scope of Python and not C++ at all, which is why it likely runs 10 times faster. So I hope all of that made sense, and if you guys have any other questions or any other things you'd like me to break down, let me know in the comments. Thanks, bye.